Hey guys, today I'm going to tell you about work related to remote drone ID, which has been done by Internet Engineer Task Force. The work hasn't been completed yet, so I will provide you new videos when it is necessary. IETF created a working group named Drone Remote ID Protocol, DRIP in short, which belongs to Internet Division. The working group works on the following items: requirements, architecture, protocol design. Working group has already published requirements. The name of this document is Drone Remote Identification Protocol Requirements and Terminology, which is an informational document RFC 9153. It lists the technical requirements for applying IETF protocols to the unmanned aircraft system remote identification. All requirements are grouped into 4 categories: general, identifier, privacy, and registries. You can find more details about each item of requirements in RFC document. I provide reference for it in video description. The architecture of proposed DRIP protocols described in Internet draft informational document named Drone Remote Identification Protocol Architecture, which is under review to become RFC. This picture illustrates a global unmanned aircraft system remote ID usage scenario. You can see that different entities communicate with each other through Internet. To satisfy requirements, working group suggested to use registries and DNS. The core concept in architecture is hierarchical host identity tag, hierarchical head in short. Hierarchical head is an entity identifier in drone remote ID protocol. It means that drones, operators, registries, and other parties participating in Internet communication can use hierarchical head as their identity. Hierarchical head contains information related to public key of identity, algorithms used for its generation, and authorities involved in registration. It gives possibility to authenticate hierarchical heads by signing broadcast or Internet messages. It also allows using DNS for lookup and reverse lookup information related to unmanned aircraft and other entities which are identified by hierarchical head. You can also think about hierarchical head as an IP version 6 address because its length is 128 bits. Address space of hierarchical heads will be excluded from routing IP version 6 addresses. So hierarchical head has nothing to do with routing Internet packets in IP layer, but can be used for routing in overlay layers. Presentation of hierarchical head as an IP version 6 address also allows reusing powerful existing Internet protocols, such as host identity protocol, transport layer security, datagram transport layer security, and others. For example, host identity protocol can provide mutual authentication and secure communication and resolve such issues as interrupting communication in mobility and multi-homing use cases. So these issues become transparent for application developers if host identity protocol is in use. The second concept is the DRIP registries. The architecture document suggests using public and private registries. They hold public and private information of DRIP participants and used in their registration. The architecture document also describes the process of making information obtained by observers immediately usable. Hierarchical heat can enable lookup not only of information regarding the unmanned aircraft, but also identities of associated entities, including means of contacting them. So an observer can instantly initiate secure communications with unmanned aircraft pilot or other participants. As for today, working group also published free internet drafts related to proposed standards, but I expect more to come. The first one is DRIP entity tag for unmanned aircraft system remote ID. DRIP entity tag, that in short, is a label for hierarchical heat in context of unmanned aircraft systems. So when I talk about that, I reference hierarchical heat. This document gives detailed description of that structure and generation, the ways to use it in communication with DNS, security and privacy considerations. From existing internet protocols point of view, that is an extension of host identity tag, RFC 7401. It adds hierarchy ID to host identity tag and introduce new parameters to make it more flexible. You can see the structure of that on this slide. The document suggested to allocate 8 bits for suit ID and add new item to support hierarchical heat in host identity protocol version 2. Orchid is overlay routable cryptographic hash identifiers, a new class of identifiers defined in RFC 7343. In context of DRIP, Orchid binds with DRIP entity public key. So that itself binds with public key as well, giving possibility to check signature and authenticate that. This slide shows an example of that path and that itself, which is just concatenation of its path. The next proposed standard is DRIP entity tag identity management architecture. This document describes the high-level architecture for the registration and discovery of DRIP entity tags using DNS. Registries are fundamental to unmanned aircraft system remote ID. Only very limited operational information can be broadcast, but extended information is sometimes needed. DRIP identity management entity, DIME in short, is an entity that vets claims and evidence from registrant and delivers back endorsement and certificates. In DRIP, each entity, such as registry, operator, aircraft, is expected to generate a DRIP entity ID on the local device, which holds public-private keys. These are registered with a public information registry within hierarchy, along with whatever data is required. Any personal identifiable information is stored in a private information registry. In response, the entity will obtain an endorsement from the registry. The DIMEs can be classified to serve several different roles, shown on this slide. The next slide shows the DIME logical components and their descriptions. The document described registration of the following items: serial number, operator, session ID, child time. As you can see on this slide, the process for registering each party is the same. This slide shows examples of how fully qualified domain name derived from dates and serial numbers. The result of registration is written in DNS and private registry with the information shown in the following table. The last protocol-related document is DRIP entity tag authentication formats and protocols for broadcast remote ID. This document describes how to add trust into the broadcast remote ID discussed in DRIP architecture. The document defines DRIP-specific authentication method carried in ASTM authentication messages. This method, when properly used, enables a high level of trust that the content of other ASTM messages was generated by their claimed registered source. The authentication approach also provides some error correction. When an observer receives a DRIP-based authentication message containing signed evidence, it should validate the signature using host identity corresponding to the DAT. The host identity should be retrieved from DNS or from a local cache. On this slide, you can see specific authentication method and message format suggested by DRIP working group. Broadcast media dictates some restrictions on volume of data in authentication message shown on these tables. The document also suggests using several authentication message types to provide trustworthiness for broadcasting messages. The document also provides recommendations for rate of sending different authentication messages. Finally, we can compile suggested protocol documents and requirements in the following tables. As you can see, almost all items, all requirements are covered by proposed standards, but I expect some minor changes in existing internet drafts to become RFC. That is it. If you like this video, please share it with your colleagues and friends. Goodbye.